So first question is, consider a gas phase reaction N2 plus O2 gives 2NO plus heat. When the pressure is increased, then the equilibrium constant will option A decrease, option B increase, option C remains unchanged, and option D increase or decrease. So I would request all of you to write the answers in the chat box, and then we'll discuss what will be the correct answer. I have one answer in the chat box by Swastika. She says option C. All of you write the answers. Okay, I have 4 answers now. Requesting everyone to write. Okay, so most of you have answered option C, that is remains unchanged. Yeah, I can see a lot of people have answered option C, remain unchanged. That is the correct answer. So basically, as I've explained you, in case of a equilibrium reaction, when the point where we say that the reaction has attained equilibrium, that is the point where the rate of the forward reaction is equal to the rate of the reverse reaction. So that equilibrium constant is not dependent on any of the other factors like substrate concentration, pressure. So pressure basically is related to the substrate concentration. So if I have to now define for a arbitrary reaction, if I have to define the equilibrium constant in terms of pressure, I can define it as partial pressure of C raised to the power of the stoichiometric coefficient, like here it is small c, lowercase c, then partial pressure of D raised to the power of small d, then divided by partial pressure of A raised to the power of small a and partial pressure of B raised to the power of small b, because those are its stoichiometric coefficient. So this is how we define the equilibrium constant for any reaction. For this particular reaction, if I have to define the equilibrium constant, it would be partial pressure of NO raised to the power of 2 divided by partial pressure of N2 into partial pressure of O2. Okay. Now, in this case, if I increase the pressure of, let's say, N2, nothing else will change. There will be no change in the equilibrium constant. What will happen? There will be a shift in equilibrium. Okay. So maybe the rate of the forward reaction will increase till the point that the rate of the forward and the reverse reaction again becomes equal. Okay. So that is the only change that is going to happen. But the overall equilibrium constant, it is a constant term. The only thing that can change the equilibrium constant is temperature. It's temperature dependent. It is not pressure or concentration dependent. Okay. So option C, remains unchanged, is the correct answer. I hope that is clear to everybody. If you have any doubt, let me know. If you have any doubt, let me know. You can write the doubt in the chat box and I can try to solve it. Moving to the next question, question number 2. What is the minimum concentration of SO4 minus that is required to precipitate Pb2 plus as PbSO4 from 0.01 molar solution of PbNO3 whole twice? The Ksp for PbSO4 is 2.2 into 10 raised to the power of minus 8. So now here we have the solubility product. Ksp is basically the solubility product. So solubility product of PbSO4 is given, and we have the concentration of PbNO3 whole twice, and we need to find the minimum concentration of SO4 minus that is required to precipitate the Pb2 plus as PbSO4. So basically, if we are adding SO4 2 minus to the solution of PbNO3 whole twice, so solution of any salt will basically dissociate the salt into its corresponding ions. Okay, so if there is a solution of NaCl, I'll take the basic example. If there is a solution of NaCl, in the solution there will be Na plus ions and Cl minus ions. Similarly, in case of PbNO3 whole twice, we will have the ions of Pb2 plus and NO3 minus. Okay, now in that particular solution, salt solution, if I keep adding SO4 2 minus, there will be a reaction between the Pb2 plus ion and SO4 2 minus ions, and PbSO4 will form, and there will be a point of like there will be a particular concentration of SO4 2 minus at which PbSO4 will start precipitating out from the PbNO3 whole twice solution. Okay, so now we have to find that particular concentration. I hope the question is clear. Whoever knows how to solve this, request all of you to solve the question. So the KSP is given as 2.2 into 10 raised to the power of minus 8, and the PbNO3 whole twice concentration is given as 0.01 molar. I'm just resharing my screen once, just to check if my pen drawing pen works. Just till then you all solve this question. Just 1 second. Is anyone able to solve the question? So I have answer option B in the chat box. All of you are saying option B. Let's see. Just give me 1 more minute. I'll just share the screen. I hope the screen is visible. So you all have answered option B as the correct answer. Let's see if that is the correct answer or not. So 2.2 into 10 raised to the power minus 6 is the correct answer. Let's see how to solve it. So we have the reaction PbSO4 goes to Pb2 plus and SO4 2 minus. So this is the this is how PbSO4 solution will dissociate into its respective ions. So after that we have the KSP value for PbSO4. So a solubility product is always defined as the concentration of the respective ions of a salt. Okay, so for a salt like PbSO4, so we have 1 mole of Pb2 plus and 1 mole of SO4 2 minus. So the Ksp will be defined as the concentration of Pb2 plus raised to the power of 1, because the stoichiometric coefficient here is 1, and concentration of SO4 2 minus raised to the power of 1. Okay, and this Ksp value is given as 2.2 into 10 raised to the power of minus 8. Now we have to answer the we have to find the maximum concentration of SO4 2 minus that can precipitate the Pb2 plus ions as PbSO4 from 0.01 molar of PbNO3 whole twice. Now, if the concentration of PbNO3 whole twice is 0.01, PbNO3 will dissociate into so PbNO3 whole twice will dissociate into Pb2 plus and 2 moles of NO3 minus. Okay, so 1 mole of Pb2 plus and 2 moles of NO3 minus. So the concentration of PbNO3 whole twice will be equal to the concentration of Pb2 plus. Okay, so 1 mole of PbNO3 whole twice will give you 1 mole of Pb2 plus and 2 moles of PbNO3 minus. Okay, this will be minus. So that means if the concentration of PbNO3 whole twice is 0.01, the concentration of Pb2 plus will also be 0.01. Now you have the concentration of Pb2 plus, you have to find the concentration of SO4 2 minus. From the Ksp formula itself, you can easily calculate. Just divide this by 0.01, so that will give you 2.2 into 10 raised to the power minus 6 as the correct answer, which most of you gave. So let's move on to the third question. In the following reversible reaction, HCOH goes to HCO minus plus H plus. At equilibrium, the addition of H plus would cause. What will happen at equilibrium if we add more H plus? We have the reaction where HCOH, that is the formic acid, dissociating into its corresponding ion HCO minus plus H plus ions. So what will happen if at equilibrium we add more H plus ions? Options are: option A, decrease of HCOH concentration; option B, decrease of HCO minus concentration; option C, reduction of the value of equilibrium constant; and option D, increase of the value of equilibrium constant. Write your answers on the chat box. I see 2 answers right now. All of you try to answer in the chat box. I've just explained about the equilibrium constant and what happens at equilibrium, so you should be able to understand. Okay, I see 5, 6 answers. All of them are option B. What about others? Anyone else wants to answer? So option B is the correct answer. Decrease of HCO minus ion concentration. So what happens at the equilibrium? The rate of the forward reaction, as I've told you, basically the dissociation of HCOH into HCO minus and H plus will be equal to the rate of association of HCO minus and H plus to form HCOH. Okay. Now, if I add H plus at equilibrium, so at equilibrium everything is stable. So whatever amount of HCOH is forming, the same amount of HCOH is breaking down into the constituent ions. So there is no net change in the concentrations of reactants and products. Okay. Now, At that stage, if I suddenly add more H plus ions, what will happen? The right hand side of your reaction, there the concentration of one of the component increases, so that will automatically shift the reaction towards the left hand side. Okay, so imagine it in a way of a weighing scale. Okay, you all have seen the weighing scale that goes up, and down. So if you have two balanced weight on both the sides, it will be stable. But what will happen if I add one extra kg on one of the side? That side will go down and the other side will go up, right? Similarly, what happens in an equilibrium reaction, if you add one of the components on one side, so if I increase this component on left hand side, the reaction will directly shift towards the right hand side. Okay, because this side will now be heavy, so it will try to unload its weight towards the other side. So in this case, since we are adding the component on the right hand side, the reaction will move towards the left hand side. And for the reaction to move towards the left hand side, what will happen? The extra H plus that has been added will basically react with HCO minus, and the overall concentration of HCO minus will start decreasing, and concentration of COH will start increasing to maintain the equilibrium again. So whenever there is a chemical reaction, the reaction will always try to attain equilibrium, because that is the thermodynamically favorable condition. Okay, so whenever there is a chemical reaction going on in nature, if you disturb the equilibrium of the reaction, it will again adjust itself so that it attains a new equilibrium. Okay, so in this case, when you add H plus ions, it will shift the reaction equilibrium, and HCO minus ions will decrease. Is this clear to everybody? If anyone has any doubt in this, please let me know. Okay, so you can write your doubt in the chat box. Moving to the next question, question number 4. Calculate the approximate pH at which FeOH whole thrice gets precipitated if concentration of Fe3 plus is 10 raised to the power of minus 2 molar and value of Ksp for FeOH whole thrice is 3.8 into 10 raised to the power of minus 38. So the solubility product of FeOH whole thrice is given. You have to calculate the approximate pH at which FeOH whole thrice will precipitate. Okay, and Fe3 plus concentration is given. So I've told you solubility, how to write the solubility product in terms of the ion concentrations. So for FeOH whole thrice, it will dissociate into Fe3 plus, 1 ion of Fe3 plus and 3 moles of OH minus ions. Okay, so 1 mole of Fe3 plus ion and 3 moles of OH minus ions. Now, if you have to write the solubility product for that, how will you write it in terms of Fe3 plus and OH minus concentration? And then you have the Fe3 plus concentration, so you can calculate the OH minus concentration, and from that, in the previous class, we learned how to get the pH from OH minus ion concentration. So all of you try to calculate this. Use your calculators if necessary. Calculate this and tell me the answer. What would be the approximate pH? I request all of you to use your notebooks and calculators and calculate. You will only learn when you will do it on your own. Okay, I have one answer, option A. What about others? Everybody solve. I've given you enough hint, So I think you will be able to solve it. You have the solubility product given 3.8 into 10 raised to the power of minus 38. Write it in terms of concentration of Fe3 plus and OH minus ions. Then calculate the concentration of OH minus. From that, we have learned how to calculate the pH in the previous session. So you should be able to calculate that. Okay. I have 3 answers in the chat box. All of them are option A. What about others? Okay. Getting more answers now. I'm getting answers only from 7-8 students out of 20 students, almost 20 students in the class. Others, if you have any doubt, please let me know. I'll help you out with the doubt. And if you don't have any doubt and you know how to solve it, please solve and tell me the answer. Okay. So most of the answers in the chat box are option A. So let's see if that is the correct answer or not. That is the correct answer, 2.2. So let's see how to solve this. So you have FeOH whole thrice. I told you when it dissociates in the solution, it will give Fe3 plus ion, 1 mole of Fe3 plus ion and 3 moles of OH minus ions. Okay. So the solubility product will be now written as the concentration of Fe3 plus multiplied by the concentration of OH minus ions whole thrice. I told you the stoichiometric coefficient, the number of moles that is given goes on the power of the concentration. So Fe3 plus has 1 mole, so Fe3 plus, concentration of Fe3 plus raised to the power of 1 and concentration of OH minus raised to the power of 3. So this is the solubility product. Now this is equal to 3.8 into 10 raised to the power of minus 38. Fe3 plus concentration is given as 0.01 or 10 raised to the power of minus 2. So from that you can solve for OH minus concentration. So you first divide it by 0.01 and then you take a cube root of this. So when you take a cube root of this, the OH minus ion concentration will be 1.56 into 10 raised to the power of minus 12. And this value can give you pOH. So if you remember from the previous class, we had studied pOH can be defined as minus log of OH minus ion concentration. Like pH is defined as minus log of H plus ion concentration. Similarly, pOH is defined as minus log of OH minus ion concentration. So you have OH minus concentration, so you can calculate the pOH. And we had also learned that pH is equal to 14 minus pOH. So these two informations have been taught in the previous session. If you haven't attended that session, I would request you to go back and look into that session first. You should know this by now. So you have the pOH value. From that you get the pH value of 2.2, which most of you answered correctly. So well done. The others who haven't answered, I hope this is clear. If it is not clear, please let me know. If there's any doubt, please let me know. I'll try to help you out. Moving to the next question. H2 and CO2 at initial pressures of 5 atmosphere and 10 atmosphere respectively reacts at 1000 degrees Celsius to attain equilibrium. H2 plus CO2 gives H2O plus CO. Calculate the approximate partial pressure of H2O at equilibrium if Kp is given as 0.6 at 1000 degrees Celsius. So the partial pressure of initial partial pressure of H2 is given and CO2 is given as 5 atmosphere and 10 atmosphere respectively. we have to calculate the partial pressure of water when we have to calculate the partial pressure of water at equilibrium, and the equilibrium constant is given. Okay, so the options are 7.34, 73.4, 2.95 and 29.5. So all of you again use your notebooks and calculate. Those who know how to calculate this, calculate and tell me the answer quickly in the chat box. Those who don't know the answer, wait for the detailed solution, and after that if you have any doubt, please ask. So the initial partial pressures of H2 and CO2 is given, and initially the product concentration, when the reaction is just starting, the initial product concentration would be 0. And then at equilibrium, you will have to see what would be the concentrations of H2, CO2, H2O and CO. Okay, and based on that you have to define the equilibrium constant. Anybody try to solve this question, everyone? Did anyone solve this? Nobody knows how to solve it? Okay, I am getting answers now. Option C. 3 people are saying option C, 2.95. Okay. What about others? It's okay if you can't solve it. I'll discuss the solution. Okay, let's see the solution. I have option C as the cumulative answer. So that is the correct answer, 2.95 atmosphere. Let's see how to solve it now. So we have the reaction H2 plus CO2 goes to H2O plus CO. Okay. So initially the pressure of H2 is given as 5 atmosphere, CO2 is 10 atmosphere, and I told you initially the pressures will be 0 for the H2O and CO, which are the products. Okay. At equilibrium, there will be some amount of H2 and CO2 consumed to form H2O and CO. So let's say X atmosphere is the pressure at equilibrium. Okay. So since everything is in like the moles of the reactants and products are 1, So 1 mole of H2 and 1 mole of CO2 is giving 1 mole of H2 and 1 mole of CO. So in that case, whatever is decreasing from the reactants, that amount will be added in the product. So 5 minus X, because X is the equilibrium partial pressure. So 5 minus X would be the partial pressure of H2 at equilibrium. 10 minus X would be the partial pressure of CO2 at equilibrium. And at the product side, 0 plus X would be the partial pressure of H2O, and 0 plus X would be the partial pressure of CO. Okay. So now from this, at equilibrium, how do we write the equilibrium constant? We write the equilibrium constant as the partial pressure of the products multiplied by the number of products and divided by the partial pressure of reactants. So we have partial pressure of H2O multiplied by partial pressure of CO divided by the partial pressure of H2 and multiplied by partial pressure of CO2. So here it is given. This is how we define the equilibrium constant based on the partial pressure. Sorry. So here the equilibrium constant is given as 0.6. The partial pressure of H2O and CO are given as X. So X into X divided by 5 minus X multiplied by 10 minus X. So this will become a quadratic equation. So you can solve this. 5 into 10 is 50. And then this will be minus 10x minus 5x. So that will be minus 15x plus x square, because minus x into minus x would be plus x square. This whole thing, the denominator can go on the left hand side. So 0.6 multiplied by this is equal to x square. X into x will be x square. And if you solve this, if you open the brackets, you will get 0.4 x square plus 9x minus 30 is equal to 0. We can take the x square here. So this is a quadratic equation. You all must have learnt in school how to solve the quadratic equation. So x will be equal to minus b plus minus b square minus 4ac divided by 2a. And you can put the values in, and you will get two values. One will be negative, so you can ignore that because partial pressure cannot be negative, and the second value will be the positive value, which is the correct answer. So here we are getting x is equal to 2.95. That is the correct answer. So people who have answered option C, well done. People who haven't answered, I hope this is clear now. Anyone has any doubt in this? Great. So I can move to the next question then. If you have any doubt in the previous question, write it in the chat box. I'll try to help. Next question is question number 6. Silver chromate Ag2CrO4 dissolves in water to the extent of 0.049 grams per liter at 25 degrees Celsius. Estimate its approximate solubility product. So the concentration, a maximum concentration up to which you can dissolve Ag2CrO4 is given. So basically the solubility of Ag2CrO4 is given. Okay, solubility of any salt is defined as the maximum amount of that salt that can be dissolved in the particular solvent at a particular temperature. So for Ag2CrO4, silver chromate, we can dissolve 0.049 grams in 1 liter of water at 25 degrees Celsius. That is the maximum amount of silver chromate that can be dissolved. So this is the solubility. And from this solubility, we have to calculate the solubility product. And the molecular weight is given because the concentration is given in grams per liter and not molar. Okay, so this also I have taught you in the previous session how to convert gram per liter to molarity. So use that information, convert it into molars, and find the solubility product for silver chromate. Everybody try to calculate it. Once you are able to calculate it, write the answers in the chat box, then I'll discuss how to solve it. So Ag2CrO4 will dissociate into Ag plus ions and CrO4 2 minus ions. So you decide how many moles of Ag and how many moles of CrO4 will be there. Okay, I already have two answers in the chat box. Both of them are option C. Others also try to solve it as fast as possible. See, in this class you can solve it slowly, but in the exam speed also matters along with the ability to solve a question, not in just this exam but any competitive exam that you will give in future. So try to solve it as quickly as possible. So I have 4 answers in the chat box now. Anyone else? Okay. Okay, so most of you are agreeing with option C. Let's see if that is the correct answer or not. That is the correct answer, 1.27 into 10 raised power of minus 11. So I told you Ag2CrO4 will dissociate into 2 Ag plus ions and 1 CrO4 2 minus ion. Okay, so now let S be the concentration of Ag2CrO4, or S be the solubility of Ag2CrO4. So if the solubility concentration of Ag2CrO4 is S, now 1 mole of Ag2CrO4 is giving 2 moles of Ag plus. That means for S concentration, the concentration of Ag plus ion would be 2S, right? And the concentration of CrO4 2 minus would be S, right? Because 1 mole of Ag2CrO4 is giving 1 mole of CrO4 2 minus. So the concentration of Ag2CrO4 would be same as concentration of CrO4 2 minus at equilibrium. So CrO4 2 minus would be S and Ag plus would be 2S. Now the solubility product will for this salt will be defined as the concentration of Ag plus raised to the power of 2, because the stoichiometric coefficient is 2, multiplied by the concentration of CrO4 2 minus raised to the power of 1. So now Ag plus concentration is 2S. So 2S whole square into S, because the concentration of CrO4 2 minus is S. If we solve this, we get 4S cube. So 4S cube is equal to, so in the question we have the value of S given as 0.049 grams per liter. So I told you, if you have to convert grams into moles, you have to divide it with the molecular weight. So whatever mass is given divided by the molecular weight will give you moles, and since it is given in per liter, so moles per liter would be molarity. So to get grams, to get in molarity from grams per liter divided by molecular weight, and you will get the molarity, that is the value of S. From that you can simply calculate 4S cube, take the cube of this and then multiply it with 4, and you will get the final answer, that is the solubility product of Ag2CrO4 or silver chromate. Okay, I hope that's clear to everybody. So I see 5 or 6 people have replied to this question and they have responded with option C, which is the correct answer. So well done. Others who haven't answered, I hope this is clear. Please let me know if you have any doubt in this question or any of the questions discussed till now. Write your doubt in the chat box. I'll move on to the next question. Question number 7. A reaction is in equilibrium at constant temperature. When the concentration of a reactant is increased, then the equilibrium constant of the reaction at equilibrium will. A reaction is in equilibrium, okay? Now, at constant temperature, when the concentration of the reactant is increased, what will happen to the equilibrium constant? Option A, it will increase. Option B, remains the same. Option C, decrease. And option D, initially increase and then decrease. We have already discussed this question. Write your answers in the chat box. What will happen to the equilibrium constant if I increase the concentration of one of the reactant in the reaction? I want everybody to write the answer for this. I have already discussed what happens to the equilibrium constant. So this should be understood by each and every one of you, because this is the basis of equilibrium and equilibrium constant, and this is something you must have studied in schools as well. So I hope this concept at least is clear to everybody. I see a lot of people have answered, but still not all of you are answering. Only 7-8 people have been answering throughout the class. What about others? Even if you are not answering, I hope you are understanding. That is more important. I would like if you can answer as well, but it's okay. So option B is the correct answer, as pointed out by most of you. So I told you there's no change in the equilibrium constant for when pressure or concentration of reactants and products are increased or decreased, because the equilibrium constant, it is independent of the reactant and product concentration. It only depends on the temperature. So at any given temperature, the equilibrium constant will remain constant, will remain unchanged, no matter whatever factors you are changing. If you are increasing the concentration of reactant, the equilibrium will shift towards the product side, and the reaction will attain a new equilibrium where the equilibrium constant, the value of equilibrium constant will be the same. Okay. So changes in the concentration of reactants and products do not alter the value of equilibrium constant. The system will shift its equilibrium position according to the Lee-Chatelier's principle to maintain the same K equilibrium at a given temperature. So at a given temperature, the equilibrium constant is going to remain unchanged. Okay. So all of you have answered option B. Well done. I hope this is clear to everybody, because this is the basic point of equilibrium constant. Okay, moving on to the next question, that is question number 8. The solubility of a sparingly soluble salt, silver sulfate, that is written as Ag2SO4, is 7.5 into 10 raised to the power of minus 5 molar. So it's a sparingly soluble salt, so it's not very soluble, and the solubility is given as 7.5 into 10 raised to the power 5 molar. That means 7.5 into 10 raised to the power minus 5 moles of Ag2SO4 can be dissolved in 1 liter of water. Like, that is the maximum amount of Ag2SO4 that can be dissolved. Calculate the approximate solubility product for the salt. Okay, so again, solubility is given, you have to calculate the solubility product. So we have done this question previously. All of you solve it quickly and tell me the answer in the chat box. Ag2SO4. First, see how it is going to dissociate. What are the respective ions? Write the solubility product in terms of the ion concentration. Then assume the solubility, the concentration, the solubility concentration as S. Then what would be the concentration of the respective ions? And then based on that, define solubility product and calculate, and the value of S is already given. Calculate for solubility product. We just solved one of the questions that is similar to this one, so you should now be able to solve this question quickly. You know how to solve this kind of questions, right? Write your answers in the chat box. Okay. Titli has answered option A. What about others? What about others? Only one person was able to solve. We just solved this question, right? Two people have answered option A. Okay. Okay, now I think you guys are able to solve. Most of you have answered option A. So let's see. That is the correct answer, 1.687 into 10 raised power of minus 12. Let's see how to solve this. So Ag2SO4, it is similar to the previous question where we solved for silver chromate. So like silver chromate, silver sulfate is also a sparingly soluble salt. Ag2SO4 will dissociate into 2Ag plus, because there are two ions of silver. So 2Ag plus SO4 2 minus. So 1 mole of SO4 2 minus and 2 moles of Ag plus. Okay. So now the solubility of Ag2SO4, let's say it is S, then concentration of Ag plus would be 2S and the concentration of SO4 2 minus would be S. And the solubility product will be defined as Ag plus concentration raised to the power of 2 multiplied by SO4 2 minus concentration, that is 2S whole square into S, that is 4S cube, and value of S is already given as 7.5 into 10 raised power of minus 5. Take the cube root, take the cube of this and multiply it by 4. You will get the answer as 1.687 into 10 raised power of minus 12. I hope everyone is able to solve this. People who have answered, I can see that they have solved it. What about others? Please let me know if you have any doubt. Till then, moving on to the next question, question number 9. The solubility product of PbI2 is 8.5 into 10 raised to power minus 9. Its solubility is approximately. Now the solubility product is given and you have to find the solubility. Till now the solubility was given and we had to find the solubility product. So it's the same thing, you have to do the opposite. So now you have to find the value of S. Okay, so let's say the solubility of PbI2 is S. Then the concentration of the respective ions. What would be the respective ions? First you write the reaction. PbI2 will dissociate into two ions, Pb2 plus and I minus. So this write the reaction, balance reaction properly, and then if the solubility of PbI2 is S, what would be the concentration of the respective ions? How will you define the solubility product? And then solve for S. Solubility product is given, so you have to find the solubility. Okay, I already started getting answers. Very good. 3 people are saying option B. What about others? Okay, I see most of you are saying option B. Let's see if that is the correct answer or not. That is the correct answer. So how will we solve it? This is the same question as the previous one that we solved. So PbI2 goes to Pb2 plus 2 I minus. So 2 ions of I minus and 1 ion of Pb2 plus. So if the solubility of PbI2 is S, then the concentration of Pb2 plus will also be S, and the concentration of I minus will be 2S. So this will be, solubility product will be concentration of Pb2 plus multiplied by concentration of I minus raised to the power of 2, because we have 2 ions of I minus. So this will be S into 2S whole square. This will be 4S cube again. And you have to solve for S cube. So divide KSP, that is the solubility product, by 4 and take a cube root of the whole thing. And you will get the answer as 1.28 into 10 to the power of minus 3 molar. Okay. Is that solution clear to everybody? Let me know if anyone has any doubt in this. Okay. I hope this is clear then. Moving on to the next question. What is equilibrium constant for the reaction R goes to Q plus half P if the equilibrium constant for the reaction P plus 2Q goes to 2R is 60? So the equilibrium constant for this reaction is given. You have to find the equilibrium constant of this reaction where R is making Q plus half P. So if anyone is able to solve it, write your answers in the chat box. Okay, I have most of you are responding option C. I see one person, Mobani, has answered option B. Okay. Okay, she is also changing her answer to option C. Okay. Okay, so let's see how to solve this question. Option C is the correct answer. So basically for the reaction P plus 2Q goes to 2R, the equilibrium constant is given as 60. How will we define the equilibrium constant for this reaction? It would be the concentration of R raised to the power of 2 divided by the concentration of P into concentration of Q raised to the power of 2. Okay, so R square divided by P into Q square would be 60. Now, if we take a reverse reaction of this, it would be 2R goes to P plus 2Q. Okay, just the opposite thing. For the reverse reaction, the equilibrium constant would be Q square multiplied by P divided by R square. And if you see, this is exactly reciprocal of the above reaction, because it is reciprocal, it is the reverse part of this reaction. So the equilibrium constant will be the reciprocal of the initial reaction. So that is 1 by 60. So this is 60. So this will be 1 by 60. Now the reaction that is asked in the question is R goes to half P plus Q. So the equilibrium constant for this will be P raised to the power of half multiplied by Q divided by the concentration of R. Now if you take the square root of this equation, the second equation that is given, P into Q square by R square, if you take a square root, you will get P raised to the power of half into Q, because Q square, if you take square root of Q square, it will be Q, divided by R square. If you take square root of that, it would be R. So basically, the reaction that is asked in the question will have the square root of the equilibrium constant of the second reaction. So 1 by 60 raised to the power of 1 by 2, or square root of 1 by 60. So option C is the correct answer. Okay. So all of you answered it correctly. So well done. Others who haven't answered, let me know if you have any doubt in this question. I can explain. I hope this is clear to everyone. Moving to the next question, question number 11. The reaction H2 plus I2 goes to 2HI has a partial pressure of 0.326 atmosphere of H2, 1.625 atmosphere of I2 and 5.324 atmosphere of HI. Calculate the equilibrium constant for the reaction. So the atmospheric pressure of, so the partial pressure of reactants and product is given. You just have to calculate the equilibrium constant. So you know how to write the equilibrium constant in terms of partial pressure for a given reaction. Write it, put the values, and then solve it. This is a very direct question. Just put it in the formula and solve it. So Kp will be, how will we define Kp? Kp would be defined as the partial pressure of Hi raised to the power of 2, because the stoichiometric coefficient of Hi is given as 2, divided by the partial pressure of H2 and multiplied by the partial pressure of I2. So all the values are given, just replace the values there and calculate for Kp. I have one answer already in my chat box, option A. What about others? Solve this quickly, everything is given in the question. Okay. Okay, I see everyone is answering option A, 53.5. I think that's the correct answer. Let me check. Okay, most of you have answered 53.5. So let's see if that is the correct answer or not. That is the correct answer. So this is how we will solve it. So I told you H2 plus I2 goes to 2HI. The partial pressure of each component is given. To define the partial pressure, to define the equilibrium constant for this reaction, it would be partial pressure of Hi raised to the power of 2 divided by partial pressure of H2 into partial pressure of I2. So just put the values 5.324 into whole square divided by 0.326 into 1.625. If you solve this, you will get the answer 53.5. Okay, this is a straightforward question. I hope this is clear to everybody. Still, if anyone has any doubt in this, please ask. Others who haven't answered yet, I hope this is clear. It is very straightforward. I don't know why you are not answering. You just don't want to answer, or you are not even listening to the class. But if you are attending this session, I would request you, all of you, to try to solve these questions. It will help you with your assignment as well as with your final exams. So everybody solve. Okay. If there's no doubt, I'll move to the next question. That is question number 12. Solubility of MX, a sparingly soluble salt having molecular weight of 170 in water at 25 degrees Celsius, is 0.00179 grams per liter. Calculate the solubility product. So you have to calculate for the solubility product. The solubility is given as 0.00179 grams per liter. The molecular weight is given as 170. So you can use the molecular weight to calculate for molarity. Then you will have the solubility. It's arbitrary salt. It's a hypothetical salt, MX. So it will dissociate into M plus and X minus ions. So you can write the reaction accordingly and you can define the solubility product. for the salt and calculate for the solubility product. Solubility is given, you have to calculate the solubility product. We have already solved such questions, so you should be able to solve it quickly. All of you solve it and give your answers in the chat box. So it is 0.00179 grams per liter. First you calculate it in molarity. I already see there's one answer in the chat box. Okay. Only 2 people have been able to solve this. We have already solved such questions, so you should be able to solve these type of questions quickly. Okay, now I'm getting more answers. All of them are option C. Okay. Okay. So option C is the correct answer. You all have solved it correctly. So the solubility is given as 0.00179 grams per liter. So first you have to convert it into molarity. So for that I've told you, divided by the molecular weight. Molecular weight is given as 170. So the molarity comes as 1.053 into 10 raised power of minus 5. Now the solubility product for this salt Mx will be defined as the concentration of M plus multiplied by the concentration of X minus ions. Since both of them have one stoichiometric coefficient, it is mx, so it will be, the power will be 1 for both, so this will be s into s, that is s square. Now the value of s is already calculated as 1.053 into 10 raised power of minus 5. Now take the square of this whole thing, you will get the answer as 1.1087 into 10 raised power of minus 10. I hope this is how you all have solved, and I hope there's no doubt in this. Anybody, if you have any doubt, please write it in the chat box. This is clear to everybody. So by now, I hope you have understood the concept of solubility and solubility product, how these two things are related. This part should be very clear to everyone. Okay. Moving to the next question. Question number 13. You are determining the hardness of water sample by doing titration with Na2 EDTA or sodium EDTA solution and using EBT, idiochrome black tea, as an indicator. The stability of the complex Ca2 plus EDTA is compared with the stability of Ca2 plus EBT. Which of the following is true? So you are determining the hardness of the water sample and you are performing a titration using sodium EDTA and EBT. EBT is the dye that acts as the indicator, idiochrome black tea. And sodium EDTA, it's a metal chelator. So EDTA can chelate the metals from the solution. So hardness of water is defined as the amount of metal ions present in the water. So mainly Ca2 plus and Mg2 plus ions. So you have to determine the concentration of Ca2 plus ion to determine the hardness of water. Okay. Now, which of the following statement is true? Option A, stability of Ca2 plus EDTA complex is lower than the Ca2 plus EBT complex. Option B, stability of Ca2 plus EDTA complex is higher than the Ca2 plus EBT complex. Option B, stability of Ca2 plus EDTA complex is very similar to that of Ca2 plus EBT complex. And option D, stability of Ca2 plus EDTA complex is first higher and then it is lower than the Ca2 plus EBT complex. So if you know the correct answer, you can tell. So this is a titration process. So depending on the binding affinity of calcium ions with the EDTA and EBT, like complex of Ca2 plus with EDTA and complex of Ca2 plus with EBT, these two are compared because their binding affinity basically defines how will you determine the, how will you perform the titration. I hope all of you have performed titrations in school, so you must know the concept, the principle behind titration. I see 3 people have answered option B. Stability of Ca2 plus EDTA complex is higher than the stability of Ca2 plus EBT complex. Okay, that is actually the correct answer. So basically, in this titration, what we do, we take the water sample that for which we want to determine the concentration of Ca2 plus. Okay, so if we find the concentration of calcium ions in the water, we can determine the hardness of the water, because if more calcium ions are present, that means the water is hard. If calcium ions are not present in the water, then we can call it as soft water. So you must have studied the concept of hard water and soft water. It's a metal ion contamination of water. So we will take, let's say we take a beaker in which we take the water sample. Now we want to determine how much calcium ions are present in this water sample. We'll add 2-3 drops of EBT, iriochrome black tea indicator, in the water sample. So whatever Ca2 plus will be present, they will bind to this EBT, and the bound EBT, the Ca2 plus EBT complex, that complex will give the color around like purplish black color to the water. Now we'll take a burette and we'll fill it with sodium EDTA solution. We'll make a particular concentration of sodium EDTA solution and we'll fill the burette with that solution. And now we'll start adding the sodium EDTA solution dropwise to this EBT Ca2 plus complex that is formed in the water sample. Okay, so now there will be a point where there will be a color change from purplish black to blue. That color change basically indicates the end of titration, and that color change occurs when all the Ca2 plus EBT complex have now been broken. Basically, since Ca2 plus has more affinity towards EDTA, what will happen? EDTA will start pulling the Ca2 plus towards itself, making Ca2 plus EDTA complex, which is more stable than Ca2 plus EBT complex. Okay, so now once we start adding the EDTA solution in the water sample, all the Ca2 plus will start binding to the EDTA, and there will be a point where all the EBT molecules will be free of Ca2 plus, and the free EBT gives a blue color to the solution. The Ca2 plus EBT gives a black color to the solution. So the change from black to blue will indicate that all the Ca2 plus has now bound to EDTA, and this concentration, like then we can see how much EDTA solution was required for this color change to occur, and based on that we can determine the concentration of Ca2 plus. So whatever the concentration of EDTA will be based on the burette reading, you can directly calculate the concentration of Ca2 plus, because that much EDTA was required to take all the Ca2 plus from the solution. Okay, so this whole thing is based on the principle that EDTA complex with Ca2 plus is more stable than the calcium EBT complex. Okay, Is this clear to everybody? Anyone, if you have any doubt in this, please ask. I can explain again. I hope this is clear to everyone. You can write your doubt in the chat box. Moving on to the next question, question number 14. 3.3 moles of A are mixed with 5.5 moles of B, and the mixture is kept in 1 liter flask till the equilibrium A plus 2B goes to 2C plus D is attained. Okay, so reaction is given. The starting concentration of A and B is given as 3.3 moles and 5.5 moles. At equilibrium, 0.3 moles of C are formed. So at equilibrium, the concentration of C is given. You have to calculate the equilibrium constant. So A plus 2B goes to C plus D. This is the reaction. The initial concentration of A and B are given. The final concentration at equilibrium for C is given, and you have to find the equilibrium constant. Write the reaction clearly in your notebooks and then write the initial concentration and equilibrium concentration. Define the equilibrium constant based on the equilibrium concentrations. Then you will be able to solve the equilibrium constant. All of you solve this question. Is anyone able to solve this question? Okay. Okay, I see answers coming in the chat box. Option B. 3 people have answered option B. What about others? Did all of you get this answer? Okay, I see one option A also here. Most of you are answering option B. There's one person who has answered option A. Let's see the correct answer. So option B is 1.585 into 10 raised power minus 4. That is the correct answer. So this is how we solve such questions. So your initial concentrations of the reactants is given. initial concentration of the product will be 0. Let's say at equilibrium, X moles of A is consumed from A. So A minus X would be the concentration of first reactant. The second reactant is 2B. The stoichiometric coefficient is 2. So if X moles of A are consumed, then 2X moles of B will be consumed, because for each mole of A, we need 2 moles of B. Okay, so X moles of A is consumed at equilibrium. So 2x moles of B will be consumed. So B minus 2x. And the product also has 2 moles of C. So for each mole of A, we have 2 moles of C. So 0 plus 2x, and this will be 0 plus x, because 1 mole of D. So 1 mole of A is giving 1 mole of D. So x moles of A will give x moles of D. Okay. So this will be the final concentration. Now final at equilibrium, the concentration of C is given as 0.3. So that means the value of 2x is given as 0.3, A is given as 3.3, and B is given as 5.5. So x will be 0.3 by 2, that is 0.15. Now the equilibrium constant for this whole reaction will be defined as the concentration of C whole square, that is 2x whole square, multiplied by concentration of D, that is x, divided by concentration of A, that is A minus x, multiplied by concentration of B whole square, because 2B is there. So it would be B minus 2x whole square. Now just replace the value of x. You know the value of x, you know the value of A and B. Just replace, solve it, and you will get the answer as 1.585 into 10 raised power of minus 4. I hope this is what all of you have done. Okay, great. So this is how these questions are solved. In any case, if you have the initial concentrations and given, and you have to find the final equilibrium concentration, or you have to find the equilibrium constant, so this is how you should write the equation and define the concentrations. The initial concentration of products will be 0, and then final concentration depending on their stoichiometric coefficient, depending on their moles. Okay, so I hope this is clear to everyone. If there's any doubt, please write it in the chat box. I'll try to help you out. Next question, question number 15. Calculate the solubility of silver carbonate. The solubility product of Ag2CO3 is given as 5.23 into 10 raised power of minus 11. Again, we have solved many questions like this, so I won't spend a lot of time on this. Quickly solve this question. Solubility product KSP is given as 5.23 into 10 raised power of minus 11. What would be the solubility of Ag2CO3? So the formula is also given for the salt, so you can easily calculate. Calculate and let me know. The solubility product is given for Ag2CO3. Okay. 2 people have answered option B. What about others? Everybody solve. So Ag2CO3 will dissociate into 2 moles of Ag plus and 1 mole of CO3 2 minus. So the solubility product KSP can be defined as the concentration of Ag plus whole square multiplied by concentration of CO3 minus. Okay, most of you have answered option B. So let's see if that is the correct answer or not. So 2.35 into 10 raised power of minus 4, that is the correct answer. So solubility product will be defined as Ag plus whole square multiplied by CO3 2 minus concentration. If S is the solubility for Ag2CO3, then Ag plus concentration would be 2S and CO3 2 minus concentration would be S. because 1 mole of Ag2CO3 is giving 2 moles of Ag plus, so 2S, and 1 mole of CO3 2 minus, so S. So 2S whole square into S, that is 4S cube. The value of this is given as 5.23 into 10 raised power of minus 11 divided by 4 and take a cube root. You will get the answer as 2.35 into 10 raised power of minus 4. Most of you have answered option B, and by this time we have solved many such questions. So I hope this is very clear to everybody. I'll move to the next question. 2 moles of H2 and 5 moles of I2 give 7 moles of 2 moles of H2, 5 moles of I2 and 7 moles of HI are injected into 1 liter box. What would be the approximate concentration of I2 at equilibrium at 490 degrees Celsius? K equilibrium is already given. So equilibrium constant is given as 53.6. You know the reaction of H2I2 giving HI. We have discussed it in previous question. So H2 plus I2 will give 2 moles of HI. Okay. So if we are injecting 2 moles of H2, 5 moles of I2 and 7 moles of HI in the 1 liter box, we will, after some point, equilibrium will be attained where the rate of H2 and I2 forming HI would be equal to the rate of HI dissociating into H2 and I2. At that point, what would be the approximate concentration of I2? And the equilibrium constant is given. So first define the equilibrium constant based on the concentrations of HI, H2 and I2. So the reaction is H2 plus I2 giving 2 moles of HI. So everybody solve this question. Try to solve it. Give the answer in the chat box and then we'll have a discussion. Okay. I have one answer, option A. What about others? So you first write the equation in your notebook. H2 plus I2 gives 2HI. Write the initial concentration that is given for each. Write the final concentration at equilibrium. What would be the concentration? Define the equilibrium constant based on those concentrations. And then calculate the concentration of I2. So 3 people have answered option A. What about others? Everybody solve quickly. Okay. Anyone else wants to answer? Okay, let's see the correct answer. 3.5, option A. That is the correct answer. So this is how we solve it. The initial concentrations are given as 2, 5 and 7 for H2, I2 and HI respectively. So I told you at equilibrium you have to write it in terms of, let's say x moles of H2 is used. So 2 minus x moles of I2, x moles of I2 is consumed. So 5 minus x, because 1 mole of I2 and 1 mole of H2 is being consumed and giving 2 moles of HI. So for every mole of H2 there will be 2 moles of HI. So if x moles of H2 are used, then 2x moles of HI will form. So the concentration at equilibrium for HI would be 7 plus 2x. Okay. So now define the equilibrium constant, that is 7 plus 2x whole square, because the stoichiometric coefficient of HI is 2, divided by 2 minus x into 5 minus x. So just open the bracket, it will be a quadratic equation. Solve for the quadratic equation and you will actually get two values of x, but one of the value cannot be possible because if x is 6.65, then you see the concentration of I2 will go into negative because 5 minus 6.65 would be a negative value and the concentration cannot be a negative. So the x value of x we will consider as 1.48 and 5 minus 1.48 would be 3.52 or 3.52 rounded off. Okay, so option A is the correct answer, 3.5 molar. So all of you who haven't answered, I hope it is clear to you. Okay. So if there's any doubt in this question, please let me know. I'll move to the next question, question number 17. At what pH will AlOH whole thrice begin to precipitate from 0.1 molar AlCl3? So aluminium hydroxide will begin to precipitate from 0.1 molar of aluminium chloride. The solubility product of aluminium hydroxide is given as 1.9 into 10 raised to the power of minus 3. Minus 33. So you have to calculate the pH. So again, it is similar to something that we have solved in one of the previous questions. So from aluminium hydroxide, you can actually calculate the concentration of hydroxide ions, and from that you can calculate the pH. So try solving this. The concentration of aluminium chloride is given. All of you try to solve it. We have solved one such question previously, so you should be able to solve this. Everybody try to solve and give me the answer in the chat box, and then we can have a discussion. Yeah, I have one answer in the chat box, option A. What about others? Okay. I see 4 people have answered option A. Let's see the correct answer. Option A, that is 3.42. That is the correct answer. So this is how we will solve this. We have solved one such question previously. So let's see how to solve this. So we have aluminium hydroxide, AlOH whole thrice. So this will dissociate into Al3 plus ions and 3 OH minus ions. Okay. So for every Al3 plus ion, there will be 3 OH minus ions. So the solubility product can be written as the concentration of Al3 plus multiplied by the concentration of OH minus ions raised to the power of 3, because we have 3 as the stoichiometric coefficient. So the value of Ksp is already given. Value of Al3 plus is already given in form of the concentration of AlCl3. So in AlCl3, it will dissociate into Al3 plus 3Cl minus. So whatever the concentration of AlCl3 would be same as the concentration of Al3 plus ions. So you have the concentration of Al3 plus ions, so you can calculate for the OH minus ions. OH minus ion concentration, so the 1.9 divided by 0.1 would be 19. 19 into 10 raised power of minus 33. If you take a cube root of that, you will get 2.66 into 10 raised power of minus 11. So that is the OH minus ion concentration. Now take a negative log of this, so you will get POH. So POH is minus log of OH minus ion concentrations. So that is POH will come as 10.576, and then you can subtract it from 14 to find the pH of the solution. Okay. So if you have the POH value, you can easily calculate for pH by subtracting from 14. So most of you answered option A, that is the correct answer. People who haven't answered, I hope this is clear to you. Let me know if you have any doubt. Please write your doubt in the chat box. Moving to the next question, question number 18. If in an endothermic reaction at equilibrium, heat is added, in which direction of the equilibrium will shift according to Le Chatelier's principle? In an endothermic reaction at equilibrium, if heat is added, in which direction the equilibrium will shift according to Le Chatelier's principle? Option A, to the left, option B, to the right, option C, can't be determined, and option D, no shift in equilibrium. What would be the correct answer here? Okay, let's see option B as the consensus answer. So if heat is added to an endothermic reaction, it should shift to the right according to you all. Let's see. So in an endothermic reaction, the heat is consumed in the reaction, and in an exothermic reaction, heat is released in the reaction. Okay, you just have to get this concept in your head. So if it's an endothermic reaction, heat is consumed, so heat will be towards the reactant side, you can say. And if heat is released, it's an exothermic reaction, and heat will be towards the product side. Okay, so if heat is towards the reactant side in case of endothermic reaction, and we are increasing the heat, what will happen? We are increasing one of the components on the left hand side. So I've told you, if one of the component on the left hand side is increased, the equilibrium will shift to the right. So your answer is correct. The equilibrium will shift to the right because the heat will be consumed, and it will shift the direction of the reaction towards, like it will make the reaction go forward, and it will shift it towards the right hand side. If the same thing was happening in exothermic reaction, if we add heat to the exothermic reaction, basically heat is towards the right hand side, towards the product side, because heat is being released in that case. In such reaction, in an exothermic reaction, if we add heat, it will basically shift the equilibrium to the left hand side. Okay, so a change in temperature can affect K equilibrium. I have told you equilibrium constant is dependent on temperature. So for exothermic reaction, increasing the temperature decreases the equilibrium constant, and for endothermic reaction, increasing the temperature increases the equilibrium constant. Okay, is this clear to everyone? Moving on to the next question, question number 19. Consider the following reaction. N2 plus O2 gives 2NO plus heat. The forward reaction will be favored by high pressure, option B lower pressure, option C higher temperature, option D lower temperature. So if there is a reaction N2 plus O2 gives 2NO plus heat, the forward reaction will be favored by higher pressure, lower pressure, higher temperature, or lower temperature. What would be the correct answer? Okay. I have one answer, option D, in the chat box. What about others? This is a theoretical question. You don't have to solve anything for this. Quickly answer in the chat box. Write your answers in the chat box, everyone. See where the heat is and what will happen. Okay, 2 people have answered option D. What about others? Okay. Okay, so option D, that is lower temperature. So basically, I just explained. So in this case, heat is being released in the reaction. Heat is towards the product side, towards the right hand side of the reaction, right? That means this is an exothermic reaction. So for such reaction, if we increase the temperature, if at higher temp, if we go and increase the heat or increase the temperature, reaction will actually go backwards, because the reaction heat is towards the right hand side of the reaction. So if you keep on increasing that component, it will push the reaction towards the left hand side. So for reaction to go forward, you need to keep the temperature down. So at lower temperature, the reaction will go forward to attain equilibrium, where the heat dissipated here will be equal to the temperature that is given. So this is an exothermic reaction. I told you, upon lowering temperature, the reaction will go forward, and the pressure will not affect the equilibrium constant. We have already discussed this. The concentration and pressure do not affect the equilibrium constant. Equilibrium constant is only affected by the temperature. Okay, I hope this is clear to everyone. Please let me know if there is any doubt. Moving on to the next question, question number 20. The solubility product of AgCl is 5.3 into 10 raised to the power of minus 14 at 25 degrees Celsius. It's the solubility, its solubility is approximately. So solubility product is given. You have to calculate the solubility. The molecular weight of AgCl is given. So calculate the solubility. Look at the options. Options are 4.6 into 10 raised power of minus 5 grams per liter. Option B is 3.3 into 10 raised power of minus 5 grams per liter. Option C is 5.2 into 10 raised power of minus 4 grams per liter. And option D is 8.4 into 10 raised power of minus 4 grams per liter. The solubility product for AgCl is given. KSP is given as 5.3 into 10 raised power of minus 14. So what would be the solubility of AgCl? Calculate quickly. We have solved many such questions in this session. We have been solving these questions, so everybody should be able to solve this. Okay, I have one answer, option B, 3.3 into 10 raised power of minus 5. Let's see. What about others? Okay. So all of you are answering option B. That is the correct answer, 3.3 into 10 raised power of minus 5. So this is how we will solve this. AgCl will dissociate into Ag plus and Cl minus. So if the solubility of AgCl is S, the concentration of Ag plus will also be S and Cl minus will also be S. So the solubility product can be determined as concentration of Ag plus multiplied by concentration of Cl minus. Since both of them are S, KSP will be equal to S square, and the value of KSP is given as 5.3 into 10 raised power of minus 14. So S square will be equal to this. S will be equal to square root of this. So if you take square root of this, you will get 2.3 into 10 raised power of minus 7 molar. Now this is in molar, and the options were given in grams per liter. So for that, you can use the information about molecular weight. So molecular weight of AgCl is already given as 143.5. So from grams per liter to molarity, you can divide grams per liter by the molecular weight to get molarity. Similarly, from molarity to grams per liter, you can multiply with molecular weight. So molarity is given as 2.3 into 10 raised power of minus 7. You can simply multiply it by the molecular weight 143.5, and that would give you the final answer 3.3 into 10 raised power of minus 5 grams per liter. So molecular weight basically means these many grams are present in 1 liter of or these many grams, or these many moles are present in 1 liter of solution. So if the molarity is 1 molar, then 143.5 grams are present. So if the molarity is 2.3 into 10 raised power minus 7 molar, then 143.5 multiplied by 2.3 into 10 raised power of minus 7 grams per liter would be present. Okay, this is how you are supposed to solve this. I hope there is no doubt in this. Anybody, if you have any doubt, please ask. We are now moving to the last question of this session. If you have any doubt in any of the question or any doubt in general in this topic, please ask. Question number 21. The values of KSP of CaCO3 and CaC2O4 are 3 into 10 raised power minus 9 and 2 into 10 raised power of minus 9 respectively at 25 degrees Celsius. If the mixture of these two is washed with water, what is the approximate concentration of Ca2 plus ions in water? So you have the KSP given for calcium carbonate and calcium chromate. Okay, and you have to find the approximate concentration of calcium ions if both of these are mixed and washed with water. Okay, so if these two are mixed, there will be common ion effect. There will be a common ion, that is the calcium ion, that is present in both. So if you mix it, the concentration of calcium ion would be influenced by both of these ions, and depending on the solubility of these two salts, when we wash it with water, there will be, depending on the solubility, whatever salt of calcium, whatever amount of calcium carbonate and whatever amount of calcium chromate will get solubilized in water, that amount will determine the amount of calcium ions present in water. Okay, so from KSP of both the salts, you can actually calculate the individual solubilities of these two salts, and based on the solubilities, you can calculate the calcium ions from each salt and add them together to get the final concentration of calcium ion in water. So we have solved for the solubility from solubility product. So here the same thing is given. Take your time and solve it. I can already see one answer. Okay, two answers are there. Very good. Okay. Okay, all of you are answering option C. So this means I hope you all have understood how to solve such questions. So this, here I have given a detailed solution just for the explanation purpose. So for calcium carbonate, the solubility product is given. So based on that, you can calculate for the solubility. And for calcium chromate also, solubility product is given, so you can calculate the solubility, and then based on that, you just have to add the total concentration of Ca2 plus from both, and you will get the final concentration. We have already solved such questions. This is just a very detailed solution. If this seems confusing and if you have solved it in some other way, it's totally okay. The main point is to get the correct answer. Any doubt in any of the question? This was the last question of today's session. So let me know if you have any doubt in any of these questions or any of the topics in general. I'll try to help you out. Yeah, ask whatever your doubt is.
Ma'am, there was this question that the KSP value of GDOH whole 3 is 2.8 into 10 to the power minus 23. The
Hmm.
pH at which GDOH whole 3 begins to precipitate is. Now
Hmm.
here I have calculated the KSP value.
Hmm.
The S is coming to be 1 into 10 to the power minus 6 molar.
Okay.
Now ma'am, for OH minus ion, it will be, should it be 3 into 10 to the power minus 6 molar? Because it is
So
3s, so it is a bit
it is
confusing.
GDOH whole thrice, right?
Yes, ma'am.
So GDOH whole thrice means it will dissociate into GD plus and 3OH minus. Okay.
Yes, ma'am.
Huh. So whatever S you are getting from the KSP, that would be so for OH minus, it would be 3S whole cube. Like for this thing, the OH minus concentration would be 3S. Okay. So whatever S you are getting,
Yes,
it will
ma'am.
be 3 times of that for OH minus concentration. And then from that, you can calculate the POH and pH. It is similar to what we have solved in one of the question, right?
Yes, ma'am. Thank you, ma'am.
Yeah, this is similar. So instead of GDOH whole thrice, you have ALOH whole thrice. So the rest of things are similar. So whatever S you are getting based on that. So S would be basically, so you have calculated for the solubility of this thing, na? GDOH whole thrice, right?
Yes, ma'am.
Yeah. Is this clear to you?
Yes, ma'am. So whatever the value of S will be coming, should we
Hmm.
multiply it by 3? Because it is 3S in case
How
of
have
OH
you,
minus.
how did you calculate S? That is the main point. So if it is GDOH
Ma'am,
whole
I have
thrice,
done S.
KSP is given. So KSP would be, is the concentration of GD also given?
Uh, Ma'am, the KSP value is given that 2.8 into 10 to the power minus
Hmm.
23.
Anything else is given?
No, ma'am. The pH is asked.
Hmm.
And I have done S into 3S cube equals to 2.8 into 10 to the power minus 23, where S
Yes.
comes to be 1 into 10 to the power minus 6.
Yeah. So your OH minus concentration is 3S. So 3S would be,
Yes, ma'am.
accordingly, you can calculate 3S and then you can calculate the rest of the things. Okay.
Okay, ma'am. Thank you.
Anyone else has any doubt?
Ma'am, if there we have taken 3S for concentration of OH, then why not here, like in ALOH whole
Here
thrice?
we haven't calculate S. I have written OH minus ion concentration as S. So basically this S does not mean the solubility here. So in this question we had the concentration of Al3 plus given already, right? So this was a different question where Al3 plus
Okay.
concentration was given and we had to calculate the concentration of OH minus ion. I think the question that is similar to the one that you guys are asking is the one we solved previously. The first. 1 minute. 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 1 This one, I think. Yeah. No, in this question also Fe3 plus concentration was given. Okay, so this is not a similar question. So basically, for the question that is given, you have to calculate based on this method. So if you consider the solubility of GDOH whole thrice as S, then concentration of GD plus would be S, and concentration of OH minus ion would be 3S. And then you'll write S into 3S whole cube. So that would give you a value, and from that you will, since you have the KSP, you can calculate for S, and based on your formula, the OH minus ion concentration would be 3S. So you can calculate for the POH and then pH. Okay. Is this clear? I can explain again if it is not clear. It's okay. You can ask if you still have doubt. Okay, great. Anyone else has any other doubt? Everything else is clear? If we don't have any doubt, then I can end this session. Anyone else wants to ask any question? Okay. So then today we can end our session now. Thank you all for joining, and I'll see you in the next session. We'll discuss the questions from week 3 in the next session. Okay. So thank you everyone for joining. I'll close the session now.
Thank you, ma'am.
Yeah, thank you. Bye bye.
Thank you, ma'am.
Yeah.